Okay, so today we're going to be starting with some improper integrals, and there are two types of these integrals. The first type, which is what we're going to be dealing with, is integrals that go to infinity. So basically, if you have infinity in one of these bounds, then that is type 1. And the second type, which I will make in later videos, are discontinuous integrals. So basically, let's say we have the integral from 0 to 1 of 1 over x dx. Now obviously 0 here would make that undefined, so hence we have more problems. But anyways, with the integral we have today, so basically from 0 to infinity of e to the x all over 1 plus e to the x all squared with respect to x. So the first thing that we would do is, well, let's focus on this infinity. Now, infinity is not a number, it's just a concept, okay? It's a concept of never ending, basically. So, you can't really have infinity here and work this integral out, okay? It just doesn't make sense. So, what some smart mathematicians thought about is that, well, let's deal with the infinity later. And how we do that is, well, first we choose a dummy variable, and I like to choose t because it looks cool. And what we do with that is, well, we take the limit as that dummy variable approaches infinity. Okay, so we'll have the same thing. And basically what this does, it says, okay, I'm gonna evaluate my integral with the bounds from 0 to t. But as soon as I'm done evaluating that integral, and when I take the limit as t approaches infinity, I'm going to send t to infinity, and we see what happens, okay? Then we really see whether we can evaluate the integral or not. So, after you've taken the limit, you can, or well, not taken the limit, after you've written down the limit, you can go ahead and solve the integral like you'd normally do. So, we have our problem area, and, well, we could see that if I let this equal to u, then it's likely that this is going to cancel. So let's take out this equal to, and let's say, well, let u equal 1 plus e to the x. Then that means that du is e to the x dx. Now, instead of solving for dx, we'd see that we have the same thing here. Well, without the squared, we have the same thing here. So we could just sub in du. So that will give us the limit as t goes to infinity, 0 to t. And we have, I'm going to write it like this. So I'm going to have 1 over, we said 1 plus e to the x is u, so u squared, and then du. Okay, so far so good. So now we can evaluate our integral like normal. So limit t goes to infinity. Now if I take this integral, it's going to be minus 1 over u from 0 to t. Why? Because this is going to be u to the minus 2. Then if I add 1 to the exponent, divide by the same thing, then we get this, okay? So I just did it in my head. Now, now in the world of x, y, because we're still in the world of u, how would that look? That would look something like this. So it's going to be limit t goes to infinity, minus 1 over 1 plus e to the x from 0 to t. Perfect, and we are almost done. Now apply FTC part 2. So the only annoying part is writing the limit all the time, but other than that, it's not so bad. So applying FTC part 2, get that, minus, this is still going to be a negative. So what I'm going to do here, because it's a negative here, let's erase those two and make it a plus. Okay, and don't forget that this limit applies to both of these. Okay, so once again, you have to keep writing the limit until you actually take the limit. Actually, here I think we can take the limit, so erase that. Now, before we do anything else, let's see here. So if this is the x and y axis, and I have a graph going like so, and this happens to be the graph of e to the x. Now if I take this limit, that means I sub in infinity for t. Now what actually happens here? Okay, let's go on to the side and see what happens here. So here it's minus 1 over 1 plus e to the infinity. That's basically what it is, this term. So e to the infinity, let's think about this. As e is going to infinity, what is it reaching? Well, you can see that it's going and it looks like it's never ending. So this whole thing is basically infinity. Okay, so stay with me. So we have 1 plus infinity. Now infinity plus 1, that's still infinity, it does not change. And now if we remember from Math130, which if you don't, I don't blame you because I did not remember either, a constant over infinity, if we take the limit of this, which is basically what we are doing right here, then that's going to be 0. Now let's think about this. If we have a constant and we keep dividing it by a larger and larger number, then it's going to get smaller and smaller and smaller, and eventually take the limit, it goes to 0. So all in all, this is just going to be 0 plus this is 1 plus 1 over 1 plus 1, e to the 0 is just 1, so it's 1 over 2, and our final answer is 1 over 2, and this is an area, so can't have units squared. And finally, because this integral is type 1, so it's an integral that involves infinity, and also it does actually evaluate to a number, then we can conclude that this integral is convergent, and we are done. And this is the entire solution.